go ahead and record this. We're on 5.4, number 4, talking about the population of a town, and it's experiencing exponential decay. So it's decreasing. So what we do is you do not just find the average change. Do not just subtract the populations and divide by the difference in years. All right? That's the average change in population if this was linear, and it's not. They tell us it's exponential. So what we do is we throw it into the y equals ab to the x formula, with the old population being our a and the new population as our y. The number of years goes in for x, and we're going to solve for b. So take a moment to pause the video and solve for b. Divide both sides by 23,000 and take the fifth root, or raise both sides to the 1/5 power. B comes out to be 0.96, and we really didn't answer question A yet. Some students wrote that there was a 4% change. That's good, an average change of 4%. Still doesn't answer the question. It says, define variables, write an equation. So here's how I would answer A. Y equals the old population times 0.96 to the x, where x is the number of years since, when was this population recorded? 2002, and y is the population. What part of the question am I answering here? Defining the variables. We've been doing that since, I'd say, 2nd grade. All right? Don't forget to tell us what the problem is about. What does x stand for? What does y stand for? That will always help you on a lot of the tests that you're going to take later in your careers here at the high school. So, secondly, we need to use our model to predict the population in 2010. Now that we have this equation, just pop in the years that it's been since 2002 to 2010. How many years is that? 8. So put in 0.96 to the 8 times 23,000, and you should get 16,592 people. For part C, this is the question that's been coming up. And students don't know, how do we solve for the variable when we don't know the variable? Well, they want to know, when does it go below 12,000? That's going to go in for y. What we don't know is x. So at this time, until we get to the stuff that we're going to study just before the holiday break next week and the week after, all I want you to do to solve this is graph. Or you can guess and check, or you can use a table of values. Take the right side of the equation and put it in for y1. Take the left side of the equation, put it in for y2, and find out where they intersect. That will give you the number of years that it takes to reach that amount. This is foreshadowing for what we're going to learn next. We're going to learn how to solve for that variable very, very soon. You should get, what was it? 2018. So you would get x equals 16 years, which implies that it's the year 2016. 2018. Thank you. All right, the recording just jumped to this calculator, and if you're watching it from home, you're probably wondering why. We're going to go ahead and finish this up to see how we came up with x equals 16. And the reason I wanted to show you all this on the video is, if you put all the information in, when does a b to the x equal 12,000? If you just hit graph, it's probably going to look something like this. Not much, okay? The reason you don't really see anything on the screen is it's way off the screen. What did the population start with? 23 even, right? 23,000, it dipped to 18,000. We're trying to find out when it reaches 12,000. What does the standard graphing window go to? 10 people. But we have a lot more than 10. So you have to go to window and adjust it. If you want to try zoom fit, go for it. I like to adjust it manually. So the population could go down to nothing. Everybody could leave the town. It started up around 23,000. So that's going to be my Y min and max. If I would have put them up here for X, we would have gone out how many years? 23,000 years, which I don't know what the town will look like then. But I do know that maybe in 20 years, I'm guessing, maybe it'll reach that amount in 20 years. If I'm wrong, if the graph doesn't show the intersection, I come back to window and change it. So let's hit graph. I kind of know it's going to be good enough because we already said it was 16, right? So what we see here is the population of the town shrinking. And what is this flat line? That's 12,000. We want to know where they cross. What's better than trace? Second trace, which is the calculate. Number 5. How many curves do we have? 2. The curvy one and the straight one. So enter, enter, enter. And it tells us that in 15.9 years, it hits 12,000. So just beyond that is when it dips below it. So it's right around the year 2018.